Application of trigonometry. Here we have a very interesting question. It says, three circles of radii 1, 2 and 3 centimeter are mutually tangent as shown in the figure. Find the area enclosed between the three circles. So these are the three circles. Their radius is 1, 2 and 3. And we need to figure out what is the area of this space in between. Now how can we find it? Well, what we can do is we can join the centers of these circles. Then we are going to get a triangle. So if we find the area of the triangle and the area of these circles, then difference between area of triangle and sum of these sectors will give us the area of center space. So that is the strategy which we are going to follow to answer this question. Now let's find out what are the angles of this triangle. First, the length of the arms. Radius is 1 and 3, so this arm will be 1 plus 3, 4 units long, 4 centimeter in this case. 3 plus 2 is 5, so this side is 5, and 1 plus 2 is 3. So we have a triangle whose sides are 3, 4, 5. Well, some of you know 3 square plus 4 square is equals to 5 square, so this is a right triangle, right? So we do have a right triangle here, so it's kind of easy for us to find the area of the triangle, base into height, right, divided by 2. So well, if not, what we need to do is we need to find angles. Now in this particular case we have to find angles in any case, since we need to find area of these sectors, right? So let's start with finding angles now. To find each angle, let me name the vertices as A, B and C. Now angle A should be how much? Angle A, we'll apply cosine law to find angle A. The two sides adjacent are 4 and 5. So angle A is cos inverse of 4 square plus 5 square minus 3 square divided by 2 times 4, 5, right? And now we can use the calculator to find this angle. So this angle is second function cos inverse. We'll open two brackets, one for the numerator. So it is 4 square plus 5 square minus 3 square bracket close divided by bracket 2 times 4 times 5 bracket close equals to 36.869. So it gives us 36. Let's say 87. Now let's find angle B. Angle B, we know it is 90 degrees, but let's find and check it out, right? So it is angle B is 4 square plus 3 square minus 5 square divided by 2 times 4 times 3. So that gives us second function cos inverse, again two brackets, 4 square plus 3 square minus 5 square bracket close divided by within brackets 2 times 4 times 3 bracket close equals to 90 degrees, right? So as expected, that is indeed 90 degrees, right? Now we know angle A and angle B. We can find angle C, right? Angle C is equals to 180 degrees minus 90 minus 36.87, or we can write 90 degrees minus 36.87, which is equals to, so we have 90 minus 36.87, which is equals to 53.13. So we have found the three angles. Now since we know it's a right triangle, right? So we can find area of the triangle. So we say triangle ABC. So area of triangle ABC is equals to half base into height. Now angle B is 90 degrees for us, right? So this angle B is 90 degrees for us. So base into height will be these two sides, 3 and 4. So half times 3 times 4. So half of 4 is 2, 2 times 3 is 6. So we get area of 6, let's write centimeter square. Now we need to find area of each sector. I hope it's clear which sectors. So these are the sectors. Do you see these are the sectors, right? So that is sector for the big circle, and then this is the sector for the other circle, correct? So how do we find area of these sectors? So if we take away area of the sectors from the area of the triangle, we do get the area of space in between, right? How to find area of the sector? Well, let's say this one A1. We'll say A1 is area of sector in circle, which is where the center is at A. So A1 will be pi r square, the whole area, times the ratio of the angle with 360 degree, correct? Yes, so that is the formula. Pi r is 5. Pi r square is the area of the whole circle, but we are only interested in this sector. So angle A, which is how much? Angle A is 36.87. So it is times 36.87 divided by 360 degrees, correct? So that gives us area of the sector. So let's calculate this out. So it is pi times 5 square times 36.87 divided by 360. That is equal to 8.04. Now let's find the area of sector B. So I'll call them B1. So that area will be pi times radiuses for well, I did a mistake. The radius was only 3 in this case, not 5. So I'll make this correction. It is not 5 but 3. So I'll recalculate this. The radius was 3, right? This is the radius 3. Okay, so let me recalculate the previous one first. So we have pi times 3 square is 9 times 36.87 divided by 360. 2.89. So this is equals to 2.895. So I'll write 2.90. Okay. Now the second one. Radius is 1 unit, right? So it's 1 square times the angle, which is 90 degrees. So 90, that means quarter, right? Over 360. So that gives us pi times 90 divided by 360. 1/4 of a pi, which is 0.785. So 0.785. Okay. The third one, which we'll call C1, as pi times the radius of 2. 2 square. Angle for C is 53.13 divided by 360. That is pi times 4 times 53.13 divided by 360. And that gives us 1.854. So we'll round it to 1.85. Okay, so we got these three areas of the sectors, right? So sum of the areas of sectors is how much? That is 2.90 plus 0.78 plus 1.85, which is equals to 2.9 plus 0.78 plus 0.85. That gives us 4.53. Right? So we had area of triangle as 6 centimeters square, and area of combined area of all the sectors is 4.53 centimeters square. Therefore, we get our answer, which is area of space in between, right? Enclosed space. That is equals to difference of the two areas. That means 6 minus 4.53. So we get 6 minus 4.53, and that is equals to 1.47. So it is 1.47 centimeters square. So that is how we can actually calculate area of the enclosed space. So in this particular example, we are using a lot of concepts. One, we are using cosine law to find the angles, right? We are using ratio of the angles to find the area of the sector. And then of course, the strategy. Finding the area of the triangle first, taking away the area of combined sectors to find the enclosed space. I hope you appreciate the concept and you learn from this. You can subscribe to my videos and do some more related problems, and the next question which comes will be the one which will not be right angle. So that will be slightly more tricky. Try to do it. Thank you and all the best.